we're asked to find g of b plus 2. So what we're going to do is plug b plus 2 into any places we see an x in that function, and then just simplify it. The exam also is multiple choice as well, so it won't be this exact format, but these type of questions, you will be able to choose the correct answer. So we're going to plug it in. Anytime we plug in something, we should put it in parentheses. So b plus 2 squared minus 6 over 2 times b plus 2. And we're going to want to simplify this some more. With this top one, this b plus 2 squared, it's not just b squared and 2 squared, right? This, just remember, is the same as b plus 2 times b plus 2. When you got a binomial squared like that. So we're going to FOIL this. It's going to give us b squared. Outer gives us plus 2b. And there's plus 2b as well. And last is plus 4. And then we still got this minus 6. Bottom, we're just going to distribute. 2 times b is 2b. Plus 2 times 2 is squared. And then you want to combine in like terms you got up there. Just like we got some b's to combine and some constants there. So I got b squared plus 4b minus 2 over 2b plus 2. The next one is just subtraction. This is just function notation. F minus g. So the only thing you got to be careful with on this is to make sure you subtract the whole function. So all of f minus parenthesis 5x plus 7. Because that negative has to get distributed to both of these terms when you subtract. It's here and here. So we're going to get 4x squared. This becomes minus 5x, so we have a negative 4 and a negative 5, so we just have minus 9x. And then we got 12, and then it's going to become also a minus 7, so it becomes a plus 5. X squared minus x plus 5. And number 3, this is called a composition. F of g, g of f. These are those are Fogg or Goth. So what this says is another way of writing that would be f of g of x, like that. It's written this way. You need to plug g into f. Okay. F of g of x. So what you do is you take the whole function g and you plug it in wherever you see an x in f. So this actually has 2 places. You're going to replace that x with the whole g function. So it's going to be here where this x is, this whole thing. So we're going to put in parentheses x minus 1 over x plus 2. Whole thing squared minus 4 times whole thing again x minus 1 over x plus 2. We're not going to worry about simplifying that one. This would be a multiple choice, and squaring this would be a bit of a challenge. Main thing is to make sure you know how to plug it in. Does anybody remember for number 5 what you do here? It's a g of f of a number. Yeah.
2.5 into f and 0.5 into 2.
Yep, that's exactly right. Yep. We're just gonna work backwards. Plug that into there. So we're gonna do f of 5. That's 5 squared plus 4. That gives us 29. This is kind of like the recursive sequence, because then we take this answer, 29, and we plug it into g. So then g of 29 will be 29 plus 3 over 29 minus 1. We get 32 over 20. And we'll reduce that. 4 goes into both, so we get 8 over 7. Next one, we're supposed to find the real zeros. A couple ways you could do this. The first way, we just set it equal to 0. And this is a pretty easy equation, so it's not hard to solve by hand. You just set the equation equal to 0 to find the zeros. Okay. And then obviously you just solve for x. 4x is negative 9 divided by 4. So x is negative 9. You can also do this on the calculator, and we'll see some harder ones. I want to show you this on the calculator just to refresh your memory. We'll see some harder ones where you have to use the calculator as well, actually. So let's go ahead and take a look at this real quick on the calculator. If you want to pull it out here, just to kind of refresh your memory. That one would have been a little bit more challenging. The first thing that you want to make sure your calculator is in the right mode. We're not going to be using the sequence mode anymore, so you can go ahead and hit mode and make sure it's in func mode, function. So just go down, func, hit enter. Then you're going to hit y equals, and you should have your equation screen now, your y's, y1, all that stuff. And our equation was y equals 4x plus 9. So we're just going to type in 4x plus 9 and graph it. So there we go. It's just a typical linear equation. And we want to find the zero. So we're going to be looking for that place where that crosses 0. If you remember, there's a way you can do this. You hit seconds and then calc, which is that trace button there. And you'll see the word 0. That's what we want. Enter on that. And then how we find this, you'll see you have a blinking cursor up there. You want to move your blinking cursor to the left. So now it's on the left side of the 0. It's going to be down below it there. It's asking you for a left bound. So that, I'm going to hit enter because I'm on the left side of the 0. And then I'm going to move to the right, saying right bound. So move it to the right past the 0. Hit enter again. You can see we get these 2 arrows, and the 0 is somewhere in between there. It asks you to guess. We're going to hit enter one more time. And there you go, negative 2.25, which is the same thing as negative 9/8. Is our football. So either way is fine for that. What we're going to choose. The next one tells us to do slope-intercept form. So hopefully you know that. That's like 7th grade math, right? Slope-intercept form. Y equals mx plus b. All right, so in this equation, in the question, it gives us a slope, that's our m2, and it gives us an x and it gives us a y. So to write an equation, we're going to start with y equals mx plus b. We're going to replace the x, the y, and the m, and then we solve for the missing variable, which is the b. So y is 2 equals m is 2 times negative 3 plus b. And then we're just going to solve for b. 2 equals negative 6 plus b. And we just add the 6 over. Equal 8. Now with that, we can now write our equation. We're going to use this b and this m. Right, y equals mx, so 2x Also b, which is 8. It's kind of a warm up for the next quick question, which is a little bit harder. Okay, so this next one we have to find the equation of a perpendicular line to the equation given through the point that's given. Alright, so anybody know what the first thing we should do is here? Yeah? Okay, yeah, so we want to get the y by itself, right? Direct 16x over, very good. So if we're going to find a perpendicular equation, we need to know what this slope is, right? If we're going to do a perpendicular, we're going to know that slope. Exactly right. We're going to solve for the y there. Actually, I'll write it all out first. And Asante said we want to subtract the 16x over because we're trying to get the y by itself so we can figure out the slope of this equation. So negative 8y equals, when we subtract this over, I'm just going to write it at the beginning, negative 16x plus 17. We can then divide by negative 8. Make sure you divide every term by the negative 8. So then we'll have just y equals, this becomes positive 2x minus 17. So we had to rewrite the given equation first, solving for y. Now we can identify this slope as 2. So what's the perpendicular slope? Huh? Yeah, just negative. Yeah. Yep. So we just flip it and negate it, right? It's called the negative reciprocal. Flip and change sign. So a perpendicular slope is negative 1/2. So we gotta find this one first, though, which is 2. This slope is not 16. I've got to solve it. It's 2. And flip it. Right. So now we got the slope. We're also given a point, x and y. So we're going to do the same thing we just did. I like to rewrite out y equals mx plus b instead. And then just replace them. So y is 6, m is negative 1/2, x is 8. That's b. Okay, 6 equals negative 4 plus b. Add 4 over. It's m. And now we can write our equation. We use the slope that we found, negative 1/2. And we use the b that we found to write our equation. Y equals negative 1/2 x. Got a lot of steps in that one. But this should be all mostly like review stuff. The next one asks you to solve this system of equations. We covered this when we did matrices, but you can solve this any way you want to. What are some ways you guys might tackle this? Like, let's say this is an ACT question. What would you guys do? How do you solve it? Huh? Try. It's not that bad. That's not that hard. What would you guys do? See? What if it's not multiple choice?
You said it is.
Yeah, but this one's not.
This one is specifically.
Well, no, it's not on the review, but it is. Someone says, "Serious $1 million if you can solve this question. You got 5 minutes. What would you do?" Go live under a bridge. Time to sleep.
They can post people
So-
live, put them in the graphing calculator and see what happens.
Okay, that would actually work. Okay. Anybody remember anything else like from not even from this year? What when you do 11? So like substitutions or anything? Like you solve for one and then you plug it in the other one? That works. We can do that. There's another one that's similar called elimination. Remember that? You like multiply one and then add or subtract the equations. Do that. Okay. That's not from this year. That's for last year. We did these using matrices. We did a few different ways. I'm not gonna go over all of them because it would take a long time. I should just briefly talk about all of them. The one that I'm gonna just do now is called Kramer's rule. You don't have to do this. It's just a way that we did it. If you want to do one of those other methods, that's fine. Kramer's rule is the one that I'm gonna do. It's not terribly difficult. But one another thing that we did is like we wrote them like this. And remember we had to do, we called it reduced row echelon form, where like you divided or you added and subtracted. You're welcome to do that if you want to. You can even do it on your calculator if you remember how to do that. Or yeah. Another way we did this was we did inverse matrices. So we wrote it like this: 3, 1, 1, 2. X and Y equals 13 and 16. And then you multiply them by A inverse. So there's another way we did it on the calculators. And then another way we did it was called Kramer's rule. And I'm just going to do this one, but by all means do this one. You can do the A inverse idea here on this one. You can use elimination, you can use substitution. You can graph them and see where they intersect. That works too. All right, any of those is fine. If you want to do Kramer's rule, I'll show you how to do that one. Kramer's rule looked like this. It was x equals d sub x over d, and y was d sub y over d. Nice. Ring a bell a little bit. Remember we're doing that? Okay. Now to find these d's are called determinants. The big D on the bottom, what you do is you draw these bars and you do the coefficients. 3, 1, 1, 2. The coefficients there. It's like a coefficient matrix. And then a 2 by 2 determinant is pretty easy. It's just where you cross multiply and subtract. 3 times 2 is 6. 1 times 1 is 1. So 6 minus 1 is 5. It just got harder when we did 3 by 3 determinants, which you don't have to do. Okay. And then we do this d sub x. Anybody remember how you get that one? Yeah. You just swap the x column with the answers. So this, instead of having 3 and 1, you take the answers and swap them in there. 13 and 16 go in the place of the x's. We still got 1 and 2. And then we do our determinant. 13 times 2 is 26. 1 and 16 is 16. That's 10. And then you do the same thing for y. You do d sub y. So then this one you're going to swap the y's, keep the x's. 3 and 1. Swap the y's and put 16. 3 times 16, which is 48. Minus 13 times 1 is 13. Subtract and you get 35. And then you do x and y, so x is d sub x over d. D sub x is 10. D is 5, so that's 2. And y is d sub y, 35, over d, which is 5, so that's 7. So answer then is 2, 7. It's not necessarily the easiest way to do it, but it is a way to do it. Pick a method if you remember how to do these on your calculator. You're welcome to do that. And then a good thing to do is to check and make sure they work. If you plug these into both, they should be fine. 3 times 2 is 6, plus 7 is 13, so that works. 2 plus 2 times 7 is 14, 2 plus 14 is 16. So that works. But there's many, many ways to do that. The next one, we have to determine basically what transformation is happening here. So how are these shifted? A, what's happening here? Up, down, left, right. Yeah. Yeah, this one's up 3. We know it's up or down because we say it's outside. Okay. It's not inside of the function at all, it's outside the function. That goes up or down. This next one is inside, right? It's inside the parentheses there, which means it's going to be left or right. Which one is it? Yeah, left 3. So remember, when it's inside, it's opposite as well. Plus 3 actually means left, and minus 3 means right. And then this one, x minus 2 inside of the absolute value, and be right 2. Okay? So inside is opposite. Make sure you know those rules. All right, we're going to sketch this next one. This is actually an inequality, which we didn't do a lot of, but I think you'll be fine with this. We did do a lot of sketching. We had like a quiz where you had to sketch a bunch of graphs. And for the exam, you won't have to sketch it. You'll need to choose the right sketch. So don't worry about your sketching skills. Don't worry. You're just going to be choosing the right multiple choice answer. So question is, what does that graph even look like? What does the absolute value look like? Yeah. Mm-hmm. Yeah. It's V-shaped, right. Absolute value is a V-shape like that.
I have your attention, please. I have your attention, please. This is Michelle, and this is a tornado watch drill. We are under a tornado watch drill. All personnel and students
Yeah, I guess.
various locations on 3 minutes notice. No movement is required at this time. Thank you.
So if we do go into a warning, which they might do in like a few minutes, then you guys are just going to go out and line up along that other wall over there. Just sit there quiet. All right, so in graphing this, the parent function looks like this. And then what does this tell us to do? Yeah, left 5. Go to your left 1, 2, 3, 4, 5. Looks like this. All right, and a couple of things to go with this. If it's an inequality, you have to do some shading. And this, if you also notice, is less than or equal to. So also remember, if it looks like one of these two, what does that tell us? There's a line under it. What does that tell us? Okay. Right, solid line. If it doesn't, if it's just like this, it's going to be a dotted line. So we did a solid, that's good. All right, and then the last thing we need to do is shade. Don't overthink the shading. It's less than, so think about what numbers would be less than. Right, it's going to be like numbers underneath. So you just really shade either inside or outside. So that. And again, this on the exam is going to be a multiple choice. You could always pick a number and try it. You could choose a number like -2, 0. See if it works. You can plug it in. So choose -2, 0. And then that would be 0 is less than or equal to. So I have -2 plus 5. 0 is less than or equal to the absolute value of 3, which is 3. And that's true. So next up, we've got end behavior. So end behavior is talking about a function, whether it's going up to infinity, down to -infinity as we get out towards the end point. Okay. And this is called a polynomial function. Right? We had a table that we used to determine the end behavior. I'm going to draw that. You will need to know these things. They're not given to you in a formula sheet. I did actually, as I mention this now, I did put the formula sheet that you're going to be given up. This is also on there too, but the reference sheet that you're going to be given here was mostly used for the next part of the exam, which is like the trigonometry part. Your unit circle, some trig ratios, law of sines, cosines, all that stuff. And then the only thing you really need to use for the function part is like quadratic formula and I suppose the slope of the line maybe. But this is all the stuff you'll be given. Here's your trig identities as well. Again, that's mostly trigonometry stuff, so we haven't really had to use any of it yet. Let's go ahead and flip back here. So the end behavior, again, you're just going to need to know this chart. Let's say this was 4x cubed. We're just going to be looking at the biggest term. How we would describe this is being positive, because the number in front is positive, and this is an odd power, 4x cubed. Power is odd, and the coefficient there is positive. What this graph looks like is like this. It might not have the exact little humps there, but it's going to have something that looks like that. Whether it's like a 5th power, 7th power, things like that. If it was negative, say it was a negative 4x cubed. So negative and odd. It's just going to be flipped just like that. You could also have an even power. So let's say it's a positive 4x squared. Power there. So this is positive even. It's going to in some way look like that. Might have some more like stuff in the middle, but it's going to be something like that. And the last possibility would be like it's negative 4x squared. So negative and even. So those are your 4 possibilities for end behavior. Given those, what we then do is we look at what we're given. The highest term there, which is a 4x cubed, so it's going to be positive and odd. It looks like this. You're going to draw like a little coordinate point there. What this is saying is x goes to negative infinity. So this is the negative x direction. The function, the y, sometimes it'll say f of x as well. Y or f of x. Goes down to negative infinity, right? Going down. This is going to be negative infinity. And then as the x goes to positive x, it's going up to positive as well. Watch this positive. That's what we mean by the end behavior. So you may be able to just look at it and tell what the end behavior is. Right. Okay, the next part we have to find some asymptotes. You should be able to do this without a calculator because it can be hard to tell this just by looking at a calculator. Does anybody know how we find a vertical asymptote?
They have your attention footing. They have your attention footing. This is your center, director, secondary center. We are now under a tornado warning.
All right, who remembers how to find the vertical asymptote?
No, I don't.
Something knows it?
I
don't think it is.
What's that? That's going to be the horizontal axis. Yeah. So the rule for a vertical asymptote, again, you don't want to just use your calculator because it's going to be a little unclear exactly where it is. They're hard to see on calculators. Is you want to find the zeros of the denominator. So what makes the denominator 0? That makes the function undefined, essentially. But there's one other condition we got to throw on this. It's the zeros of the denominator that are what? That are not zeros of the numerator. Okay. So they have to be zeros of the denominator that are not also zeros of the numerator. We did a quiz on this as well, where you had to like find a bunch of stuff with these rational functions. What happens if it is a zero of both? You cancel out. You get a hole. So a hole in the graph. Yeah. A vertical asymptote would be a line within the fines, right? But if they were both, it'd be a hole there. So let's go ahead and try to find it. We want to know the zeros of the denominator, which means we want to set that equal to 0. And something like this is going to be something we're going to try to factor, right? 3 terms there, squared. So we want to try to think what's going to multiply to give us negative 14 and add to give us negative 5. Yeah. Good. X minus 7 and x plus 2. So they multiply to give you negative 14 and they add to give you negative 5. So then when you solve these, we'll get x equals 7 and x equals negative 2. Those are our 2 possibilities. We need to just double check and make sure that that they're not holes. So we need to look at our numerator. Our numerator, the only 0 there is 3, right? That's the obvious, okay. So these are not zeros in the numerator, so they're both okay. Again, if it's 0 of both, if one of these happened to be a 0 in the numerator, you would cross it out. That would not be a vertical asymptote. It would be a hole instead. And then the other part of this is the horizontal asymptote. You do want to look at the highest powers for this one. The highest power on the top and the highest power on the bottom. This one has a bigger power on the bottom, right? So there's a conclusion based off of the 3 possibilities. You could have a bigger power on top, you could have a bigger power on the bottom, or you could have the same powers. And depending on that, that's going to tell you what the horizontal asymptote is. So you might also need to maybe memorize these rules. Let's start with the situation we have right here, where we have the bigger power in the denominator. Bigger power in the denominator. Anybody know what the asymptote is? It's going to be at 0. Whenever there's a bigger in the bottom, it's always y equals 0. The reason why is because as you plug in big numbers into this function, the denominator gets bigger, and when you have a fraction, when the denominator is bigger, it goes to 0. Okay, so the second possibility was it be the bigger powers on top. Bigger power in the numerator.
That's a bird further on the way.
If this is the case, there is none. There's no horizontal asymptote. There could be something we call that slant or an oblique asymptote. You don't have to worry about identifying those, but if it was bigger by 1 in the numerator, then it would be a slant or oblique asymptote. But if it's, we just need to state that there is no horizontal asymptote. Bigger in the numerator. Okay. And then the last scenario is if they have the same biggest powers. We call that the degree, biggest power, in other words, so the degree, if the degrees are equal. So like, let's say for instance, it was like 2x squared minus 5 over x squared minus 3x. So we have the same biggest powers there, right? In this case, we take what's called the ratio of the leading coefficients. So then the horizontal asymptote will be at y equals 2 over 1 equals 2. So the rule there is the y equals the ratio of the leading coefficients. Ratio. So those are the 3 rules there. Alright, so we obviously have the first rule, so we have a horizontal asymptote at y equals 0. Make sure you can identify any of those. And if you did want to verify it on any calculator, you can plug it in there and check it out. But again, it's not as easy to see asymptotes. All right, let's go ahead and try this one. If we're going to try to solve any equation, first thing you would probably want to do is try to factor it, right? Is this one going to be factorable? Doesn't look like it, right? Because you got factors of 1 that add to give you 3. You do have this 4 in front, but even then, it's probably not going to be factorable. So if you can't factor something, what else can you do? Yeah. Suppose you could do that, synthetic division. You would need to make like a list of the possibilities. Is that what you're thinking? Okay, you could do that. Yeah. Anybody have another idea? Yeah, you can do the quadratic formula. Yeah. And that's what we're actually going to do here. If you made a list, that would give you the possible rational zeros, but it wouldn't tell you a list at all of the zeros. So this one is a quadratic formula one, which I do give you in the reference sheet. Here. See, it's on there, quadratic formula. You should know it already, but if you don't, it's there. So we'll have our A, our B, and our C. So x equals -3 plus or minus the square root of 3 squared minus 4 times 1 all over 2 times 4. And then just go through and simplify this. -3 plus or minus the square root of 9 minus 16 over 8. Simplify it some more. We get -3 plus or minus the square root of, this is -7 over 8. So this one doesn't have any real solutions, right? Because it's got a negative inside of there. The only other thing we can do with this is bring that negative out and make it an I. And then also you could verify this on your calculator as well, because if you plug it in, you'll see that there's no places where it actually crosses the axis.